that says, oh, this is what you ought to do. When I want to upgrade, it is a pain when you want to upgrade and you have a bunch of libraries that you depend on, and those libraries, because we use a lot of Python at Canonical, may also be used by other things in your Ubuntu OS. So you can't just upgrade them. So we have to like set up virtual environments and isolate our Python from everybody else's and our libraries from everybody else, and it's a pain. And the distro people don't like it because there's 2 copies of that same library, and there's sadness. There's wailing and gnashing of teeth when you want to upgrade. And also, we were actually running into some performance bottlenecks that were CPU related. Honestly, those things could be fixed by just fixing our Python. But what if we did a rewrite? We'll get some pros, we get some native and easy to use concurrency primitives. The most important thing here, as a Python person, is that there's this thing called the Zen of Python. You go into a Python prompt and you type import this. It will list out a little thing that is like, will help you understand Python, how to write good Python. And it has many things in it. One of those things is there should be one, and preferably only one, obvious right way to do it. With concurrency, Python does not do that. There is twisted, there's greenlets, there's threads, there's multiprocessing. There's more. Guido has a new one. Tulip. Philip Ebby had one. There's just a million. There's a million different ways to do this. And so every time you look at somebody else's code, they did it differently than you would. Whereas Go, you use Go routines, you use channels. That's what you do. Everybody does it. It is relatively easy to understand and read out. And most of your stuff is still being executed in order. I mean, you can still mutate data structures in the background that Go routines depend on, and that will cause you bugs. It has some tools for helping you not do that, but that is the thing about concurrency you have to do, and Go doesn't solve this problem. It's not magic. Some people claim to have the magic language that fixes everything. It also runs really fast. It's faster than Python, and it gives us a single binary that is Juju. There's no like whole bunch of libraries. This is actually, it just doesn't implement dynamic linking, so you don't have an option. Everything gets compiled in, which is bad because distro people hate it, because what if there's a security bug in the Go crypto library? That means you have to recompile everything. Whereas if it was dynamically linked, you wouldn't. You just replace the Go crypto library, or the C crypto library, and you're fine, theoretically. Theory is great in theory. But for us, it's amazing because we can just replace a binary. Be like, hey, here's the new Juju agent binary, use it now. And if it doesn't work, we can go back to the old binary. We don't have to delete it, we just call it a different one. All kinds of things are nice. We also decided that we wanted to have a competency in Go because Go is great for lots of problems that Python is not as great for. And we were using C++ and C for those problems. Go, I cannot believe I have not mentioned this up to this point. Go is a memory managed language. You don't have to do all your own pointer arithmetic in Go. That eliminates the largest, by far, like an order of magnitude larger than any other cause of security issues in our distro, but in any OS, is somebody has a buffer overrun. That's just like everything you see, every security issue, like Heartbleed, pointer arithmetic was done wrong. That's just the way it is. So we wanted to have a Go competency. This seemed like a good use case. Truth in advertising, I started right as this discussion about whether to rewrite in Go was being wrapped up. So I knew that there was a very high likelihood when I signed the paperwork that it would get rewritten in Go, but I didn't know for sure. But by the time I actually started, it was decided. So I didn't make this decision, but I know the logic. Another con is we had to write our own YAML parser, which is config file parser. We had to write our own MongoDB driver. We had to write our own libraries for Amazon Web Services. We had to write our own libraries to talk to OpenStack. We had a lot of libraries to write. And there aren't that many Go developers out there in the world. The corollary to this is that the people who learned Go 2 years ago were pretty much smart people. So if you found someone who knew Go, the chances that they were crap were less than if you found someone who knew Python. Which is not the most useful heuristic, because you can also figure out if somebody is crap. But it was kind of nice. You'd be like, hey, I've been writing Go. Probably a good program. Because they're the kind of person who wants to learn Go, which most programmers don't crack a book. They don't learn a new thing. They don't go to a user group. They don't do anything to get better. They just write some Java code that they learned in college 20 years ago. Yeah, I guess you can have learned Java 20 years ago. Man, I'm old.
You don't even have gray hair.
So,
Yeah, exactly.
I did in fact decide to rewrite it in Go. And I think it was a really good decision. For many of the reasons we already talked about: single statically typed binary, or statically linked binary. Statically typed binary, I don't know what that means. But we learned a bunch of things. The good news is I have never met anyone who had any trouble learning Go. Because Go is boring. It doesn't let you do any interesting, crazy things. Python lets you do interesting, crazy things. There's like under slots, under, which changes the way that object attributes are managed by the interpreter. Like, that's some crazy shit. You can do it in Python. There's no similar craziness in Go. There's no meta-class hackery in Go. There's no
classes.
Classes, really. There's
The structs.
class-like things. Struct things that are a little more classy than other structs.
Object-oriented?
Yes and
Yeah.
no. There's objects, but there's not classes. So it's not quite object-oriented in the way that it's not class hierarchies. There's no class hierarchies. So if that's what you think when you think object-oriented, which is what most people think, then it's not that.
But there's interfaces.
But there's interfaces and there's structs and there's things that are objects. They just don't inherit from some class. They implement an interface, or they are a struct. And structs can have methods. So that is like, it's kind of like an object that you would think of. But it's really easy because there's nothing complicated in Go anywhere. Like, the two hardest things to understand about Go are Go routines and channels. And those things are not hard. Like, Go is great because it is super boring. You can't do anything interesting. Which means when I read Go code, I know what the hell it is doing. Whereas when I read Ruby code, who knows what is going on. But we had some problems with Go because we took a bunch of people who knew Python and we made them use Go.
Are you going to use Go in the same way you would use Ruby as a server script?
So we use Go for all kinds of server-side stuff, yes. Like, we have a single executable binary that lives on the server that implements a HTTP interface, and we make API calls to it from other things that are Go on other machines. So we use it like, I mean, it's a general purpose programming language. We have Go QML bindings, so you can write web app, or not web apps, you can write 3D GUI apps for your phone, your Ubuntu phone. which you'll be able to buy sometime in the fall, for a lot of money. Well, not me. We're not selling it, but other people are. I lost my train of thought here. What was the question? Oh, servers. Yeah, so we use it mostly for server side. It was developed.
Something like Ruby or PHP or?
Right, it was developed by Google for server side programming. They did not really envision it being used in client libraries when they first developed. It was an alternative. So in Google, they had Python, Java, and C were their three official languages. Some other things happened, but those were the three that were official. And they each have very specific and useful use cases. Like Python is fast to write, it's easy to get a lot of things done. But in terms of execution performance, is nowhere near as good as Java or C for the same algorithm. If you write a better algorithm, you can get faster Python. And that company that I mentioned at the beginning where we did the network queue and whatever, MedX was originally written in Python. We rewrote it, or it was originally written in Java. We rewrote it in Python, and it was somewhere between 10 and 50 times faster. Not because Python is faster, but because we did it differently. Mainly because we used SQL in the same way, but that is a whole story for a different day.
Can I use it to access SQL?
Go? Yes. There are established patterns for that. It does not have something like, Python has this thing called SQL Alchemy, which is like SQL magic. That's the name. And it is amazing. Amazing. Go has nothing quite as amazing as that. But, I mean, if you just want to write SQL and make queries and use the results, Go will let you do that. No problem. The situation has changed a lot in the 2 years since I started at Canonical, and we started rewriting Juju into Go. First of all, Juju is now by far the largest open source project in Go that I am aware of. We have a couple 100,000 lines